Rotational Molding Project, ETM 2080 by Chris Ponte. For this project, we watched videos of 4 parts being constructed. The first part constructed is the duck. The product name of this part is duck. The material used is low-density polyethylene, 2 ounces of it. The mold material is aluminum casting. Aluminum is the best material used for a mold, and the mold condition is very bad. It had a lot of impurities on it, a lot of defects. Some of the machines and equipment used to make the duck were the duck mold, low-density polyethylene, the mix cup and the mix stick, the yellow pigment used to give the duck its yellow color, the oven, the backing plate, the bolts, the wing nuts, a tightening tool, a plier to pry it open, and a sink with cold water. The processing times are listed below. It took 45 seconds to clean the mold, 60 seconds to mix the mold with the yellow pigment. It took 60 seconds to insert the material into the mold. It took 90 seconds to clamp the material together. It took 90 seconds to set the backing plate into the oven, and the oven time was 20 minutes, and it took 150 seconds to pry open. The methods to measure were you read the chart for the low-density polyethylene. The measurement cup was used to ensure that the right amount of low-density polyethylene was used, and the oven dials controlled the timing and the temperature of the oven. Some of the defects found on part 1 are that the part had a very porous surface. There were a lot of holes all over the part. The pigment was rubbing off as seen in the picture. You can see that there are yellow spots on your hand, and those are coming from too much pigment being added. Marks from the mold defects. This was left because the molds that we used weren't very clean. To fix this, you should probably either spend more time cleaning the mold or get a new mold altogether. And as seen in the picture, the nose is not very good. You can see that it's a little chipped away and that there's a little hole on it. The second part to be crafted was the pumpkin. The product name was pumpkin. High density polyethylene was used, 108 grams, and this was the wrong amount. It should have been 108 kilograms. The mold was created from aluminum casting, of course. The mold condition is decent. It was much better than the duck. The machines and equipment used were the mold, high density polyethylene, orange pigment, an oven, a mixing cup and a mixing stick, a backing plate, bolts, wing nuts, a tightening tool, a plier to pry it open, and a sink with cold water. The methods to measure were to read the chart correctly. It was read incorrectly in this process. A measuring cup and oven dials. Some of the processing times are listed below for part 2. To clean the mold, it took 73 seconds. To mix and insert the material into the mold, it took 2 minutes. For this specific process, a mixing cup is not used to mix the orange pigment with the polyethylene. To clamp the molds together, it took 60 seconds. To set the mold in the oven, it took 100 seconds. The oven went for 20 minutes, and to pry open, it took 5 seconds. This process took roughly 26 minutes. Some defects are that the part didn't really form at all. As you can see in the two pictures, it really just formed the outside shell, and the part really just fell apart. Some parts did acquire the required thickness. You can see that to the left, you have that little chunk that is kind of perfect, but as you can see, the part is not together at all. The color was not even throughout the part, and I think this could be due to the fact that the material was not mixed with the pigment the right way. For the third part that was constructed in the videos that I watched, the third product was a Christmas tree. The material used to create the Christmas tree was high density polyethylene, and at least not in the video. Could happen off camera. I did not see a correct amount poured. It kind of just looked like you just threw the material in, and that's what it was. The mold used was aluminum casting, and the mold condition was decent. Some materials used for this product would be the mold, high-density polyethylene, the mixed cup and the mixed stick, the green pigment, the bolts, the wing nuts, the tightening tool, the backing plate, the oven, the plier to pry it open, and the sink with cold water. The processing times are listed below, and the methods of measurement include the oven dials and the scoops for pigment. For part 3, the Christmas tree, we had a lot of defects. The piece came out really broken up. There were holes throughout the whole product. There was a giant hole in the middle. They were thicker in some areas, as I indicated with the arrows on my pictures. It was thicker in the back right here, where your finger's pointing. And you can also see that the pigment is rubbing off really bad. In the picture to the right, you can see that your whole finger is just pretty much green. The fourth part that was constructed was the four-leafed clover. The product name is four-leaf clover. The material used to create the four-leaf clover was low-density polyethylene. The mold material, aluminum casting, of course, and the condition was decent for this mold. You can see a little scrap on the parting line, but it's not uncommon with any of the molds used in these processes. For our fourth part, the four-leaf clover, the machines and equipment used would be the mold, the low-density polyethylene, the mixed cup, the mixed stick, the green pigment, the bolts, the wing nuts, the tightening tool, the backing plate, the oven, the plier to pry it open, and the sink with cold water. Processing times are listed below, and the methods of measurement include oven dial and scoops of pigment. Some of the defects for our fourth part include that the whole part throughout was only sort of solid. It wasn't completely formed yet, as can be seen through the holes throughout the project to the right. There were lighter shades of green throughout the part, as seen to the left, and then there were also shades of the product that were a darker green. It was also raining green, as said in the video. You can see it pretty much a lot on your hands, and there's even some green water in the mold. And the bottom of this part is much thicker than the top. In the video, it's gone over in detail that there's a variation of thickness in the part. A few things that would ensure a good part. One being exact with the material added. I believe it was only for the duck part that we were really specific and exact with how we measured our material being added to the mold. Materials shouldn't be streaky in the mold. They should lie uniformly. this was an issue with the pumpkin, and as you can see, the pumpkin didn't even form all the way. I don't know if that was the main cause, but I think it definitely attributed to it. Ensure that the mold being used has little to no defects. As you can see in my photo to the left, I pulled up the duck mold. You can see on the parting line there is a bunch of leftover plastics, resins, residue, and you can see that he's pointing to a rather large hole in the middle of the mold. Being more cautious with how part is cooled. I just don't think that the whole part should be submerged underwater. I think that could damage the part. I could be wrong, but to combat this, I would maybe use a hose or try and hold it with tongs to cool the part, just so it's not completely submerged. Mixing the material with the pigment properly, so that the color is even throughout. This is seen to the right. It wasn't mixed very well with the pumpkin. Again, you could say that could have been one of the reasons why the pumpkin did not form fully. And scrape off leftover material on the parting line. Some tests on some variables that we should run. I think we should run a mold test, a cleanliness test of the mold, to test if the mold is really usable, a defects test to decide if the mold is actually really able to use, and a label test to ensure that we are reading the right amount of materials. A materials test, correct amount used, ties into the last test. A level test, ensure that the material is level throughout the mold. A clump test, ensure that there's no clumps in the material. And last test, testable variable should be the oven. You should check the temp often and check the rotation often. Some problems I had with the current process include that the low density and high density polyethylene were not measured correctly. It was measured correctly for the duck, but for the Christmas tree, for the clover and pumpkin, the material was not measured correctly. I didn't even see a measurement taken for the clover and the Christmas tree. Throughout the two videos, the pigment was not mixed thoroughly, especially in the pumpkin. The top right of the mold, there was a big orange spot where a lot of the color was. And it was not level. The material was not level in the mold, which is needed to produce a good part. It took a long time to clamp the molds together. This is just wasted time. The oven door being open to release too much heat. This would cause the heat to not be consistent, which would mean our product is not consistent. A screwdriver should never be used to pry the mold open. Instead, the mold should have a divot in it so that you can pry it easily with your hands. This could be used by mill, machine. Not all settings for the oven were correct. Low density and high density polyethylene need to be in the oven for different times. This is not accounted for. For the 4-leaf clover and the Christmas tree, there was 16 minutes without rotation. Machines should be checked to ensure rotation. Rotational Molding Project, ETM 2080 by Chris Farr. Some problems.